Hello everyone. This lab is about series convergence in Calculus 3. We're trying to expand and augment what you do in class and in the textbook with some examples and problems that have real numbers in them in hopes of giving you a different perspective and a different opportunity to get a reasonably good understanding of the material. So, we assume that from class or from the book you know about what it means for an infinite series to converge or diverge. We're mostly interested here in convergence. It means that if you add more terms, so that's what this sum here with a limit in front of it means. If you add more and more terms, then you get a finite limit. That's really what this means when you get past the notation and so on. All right, so you need to have that in your background. Again, we're going to look at this numerically as opposed to algebraically. Divergence, when it occurs, means that the limit doesn't exist. So either you get larger and larger and larger totals without bound, or there's just no limit and things flip-flop back and forth. All right, so we're going to explore in the end 6 problems and decide on their numerical evidence if they converge and approximately to what. We're going to use Excel spreadsheet because it's very well suited for displaying data, for doing simple computations, and for being well organized. Probably many of, if not all of you, have experience with a spreadsheet, so that will pay off in this lab. So I'm going to do 2 examples, and then you're going to take over. My first example is the series 1 over n to the 4th. Some of you may recognize that as a p-series, depending on where you are in the course. But in any event, that's the series example 1 is about. And example 2, which we'll get to shortly, is 1 over n plus 1 cubed log n. Now, all of the computations are done by Excel. We just need to use it productively. So along with this document that we're looking at now, there is an Excel sheet that you need to download and open. And in the upper left-hand portion of it, basically what I have is code that does the computations for the 2 series that I just alluded to. So example 1 is again 1 over n to the 4th. Example 2 is 1 over n plus 1 cubed log n. I have 2 rows for each series. So the rows have 3 columns. The first column is simply the value of n. The second column is a formula for the general term of the series, which in this case is 1 over n to the 4th. And the third column, which is the most important one, is the sum of the first n terms. So I've put formulas into the cells that take care of the arithmetic computations, and we just need to see if we can interpret what it's telling us. Okay, so I've got the first 2 terms, 1.06250, whatever that means. Well, that's the sum of 1 over 1 to the 4th plus 1 over 2 to the 4th. So if you had a calculator and you punched those 2 numbers in, you should get 1.06250. So you say, well, okay, I could have done that with a calculator. We're going to see what happens if we add more and more terms on. So to do that, you need to be able to copy in Excel. Copying in Excel is very easy, but it's also very powerful in many settings. So I'm going to do a copy. How do I do a copy? I copy the second row by holding the mouse down and highlighting those. And there's more than one way to do this, so use whatever works for you, those of you that have experience. So I'm going to copy. I first highlight those and then do a copy. In my case, I did a Control-C, but you can also go up on the toolbar and find something. And now I just go down a few rows and then press Enter. And what has happened in the process is that not only is Excel copied that second row, but it's adjusted the formulas as it goes along. So this entry right here, for example, that I'm highlighting, is the sum of the first 5 terms. So it's 1 over 1 to the 4th plus 1 over 2 to the 4th plus 1 over 3 to the 4th, 1 over 4 to the 4th, and 1 over 5 to the 4th, all added up. And apparently those compute to 1.08035. Again, nothing remarkable going on here, but now we see what the software can do, and that works out to be to our benefit. So let's go back to the problem and see what it wanted. So aside from some introductory discussion, we would like to see what the sum of the series is to 3 decimal places. Now, looking at the data that I have there, it looks like the sum is going to be 1.08, but is it 1.080? Well, it gets bigger than that. Is it 1.181? Well, it seems to get bigger than that. So now we start to look at the data in the 3rd decimal place in that 3rd column. All right, so we're looking at the data in the 3rd column, and we see 1.082. We're going to copy a little bit more. And see how that works out. So I copy a little bit more, and I see to 3 decimal places that the sum appears to be 1.082. So for the problem that I was given, which was to estimate the sum of the series to 3 decimal places, my answer is that it's about 1.082. I don't put any more numbers in the answer than that. And it seems to have taken me maybe about 10 or more terms to arrive at that. So it converged fairly quickly as series goes. Okay, so again, 1.082 to 3 decimal places. Had the problem read a different number of decimal places, then I might have had to explore further. So you have to be clear on what the directions for a given problem are. All right, so let's look at a second example. In the second example over here, I've got different series. I've done the same kind of Excel work. I've put in code that does the computations for the first 2 terms of the series. So there's the general term, there's the first term, here's the second term, computed it and added it on. So the sum of the first 2 terms is about 0.067 and so on. So let's see what the second problem was asking of us. The second problem would like 4 decimal places. Now notice that you can't have an n equals 1 term here because you would have the log of 1, which is 0. You divide by 0 and things go badly. So the series starts at 2. So there's the general formula. I now copy that again, and I'll go down maybe to about 20 places or so. and have a look at what's going on in the third column. So all of the items of interest, once I've done a copy, are over here in the third column. We'll highlight that a little bit. So let's see what's going on to 4 places. So I don't see anything stabilizing yet in the 4th decimal place. If the problem had asked only for 3 places, I'd start to be suspicious that the answer was 0.081, but we're not sure about that 4th place. So we're going to copy some more. Copying is easy. You can copy all you want. I've done examples in class where I made 1,000 copies. Excel doesn't really care, and your computer has a lot of memory. So we copy the last row again, and we'll go down and maybe make 100 copies or so. So we keep looking at the 3rd column and the 4th decimal place. So I see 0.0815, but now I see 0816, so I'm not there yet. 0816, excuse me, 0.0817. And while there are changes going on, they seem to be in the 6th decimal place. So at this point, I'm pretty confident that I've got a sum that's about 0.0817 to 4 places. So I'm going to stick with that for my answer. How long did it take to get me there? Well, 2 different people could have different opinions on that. Looks like it took about 75 terms or so. So I would say roughly 75 terms. So my answer is that the sum to 4 places is about 0.0817, and it took me about 75 terms to arrive at that. So if one of you says, well, I think it's 76 terms or 78 terms or 69 terms, good, we're in agreement. But we also should be in agreement that it's 0.0817 to 4 places. All right? So to summarize this, in software terms, you need to be able to copy that last row. Then you need to look at the numbers in the 3rd column and see to the number of places you're interested in when things seem to stabilize and you believe you can estimate the answer. All right, so that's your job in 6 problems. All right, so what are the 6 problems? Well, they're stated in 2 places. In the sheet, in the document for the lab, on page 8, so I'm now looking at page 8, there's the 6 problems. They're all highlighted in green. And you want to fill in what you believe the approximate sum is. And you want to put how many terms it took to get there. Okay. You might see a series that diverges. If so, just check off that it diverges and why you think it diverged. And that's it. Do that for all 6 problems. When you get all done, print, use the print in Excel, use the print in Word, and print just page 8 to a PDF file. Right? So you're going to want to fill your name in up here. Just type it in. You're going to want to print page 8 to a PDF file and give it a name that indicates what's going on. So lab 2, MA1023, and maybe your first initial and last name. The file type should be PDF, and you upload that to Canvas. Okay? So you don't need to print the whole document. just wasting space, and whoever reads it needs to get down to page 8. All right, so there's that for the assignment, but now how does that play out in Excel? In Excel, I have put all 6 problems in moving to the right. So I've put what the series is, should match up with what's in the document. I've put the first 2 rows of the series like in the examples I show. And then all you need to do in each case is copy rows and see what you see for an emerging pattern. So it all comes down to your willingness to look at the numbers that come out for the sums and see if they're approaching a limit, and to the number of decimal places required of the problem, what that limit seems to be. All right? So that's the job. If you have questions, please ask someone. Feel free to discuss it with other people, but analyze those numbers and see what you can come up with for sums. Okay, thank you very much.